So this is going to be about section 7.3, which is sampling distributions for means. So let's talk about what a sampling distribution is first, and then we'll talk about what it means to do a sampling distribution on means. So a sampling distribution is we repeatedly take samples of the same size from a population and look at the distribution of their statistics, in this case, a mean, okay, or a proportion, which would be in 7.4, okay? So we repeatedly take samples of the same size from a population and we look at the distribution of their statistics. A sampling distribution for means says that we're going to look at the sample means and see what their distribution looks like. And what we find is that for a sampling distribution for means, when we're given information from the population, the actual sampling distribution looks the same every time. So let's talk about it. What are we given? We're given a population mean, mu, and a population standard deviation, sigma. We're also given a sample size, which we call lowercase letter n. So we're given all that information. And what we do with that information is we create a new normal model, which is the sampling distribution. So we make a normal model. The mean for our normal model from the population, or sorry, let's actually start the other way. We say that all of this together gives us a population normal model with mean of mu and a standard deviation of sigma. So that's only from the population. We use that to create the sampling distribution. So our sampling distribution looks like this. This is for a mean. It also follows a normal model. The mean is the same as the mean from the population, but the standard deviation is the population standard deviation divided by the square root of the sample size. So this is the mean for the sampling distribution, and that is the standard deviation for the sampling distribution. So what we have now is a new normal model that we can use to find the mean and the standard deviation of, and we can then use normal CDF to answer any questions that we might have, because now we're looking at a normal model. So the process for these types of questions looks like this. Questions for sampling distribution for a mean. First thing we do is we find the mean and standard deviation for the sampling distribution. So we compute a mean, which is the mu, and we find the new standard deviation by taking the population standard deviation and dividing by the square root of the sample size. So that's the first thing that we do. So we find the mean and we find the standard deviation. That's step one. Step two is to use normal CDF and the sampling distribution to answer the follow-up question. So whatever the follow-up question is, it can always be answered by using the normal CDF function in the calculator along with the information from the sampling distribution. So it's our job to decide if we're talking about a sampling distribution based on the language or if we're talking about the normal model based on the language. And we have to use what's given in the wording to help us assess what's going on in each particular problem. The last thing we have to talk about in this particular section is the central limit theorem. So I'm going to go ahead and make another section here, and we're going to discuss the central limit theorem. And the idea here is that we can use the normal model regardless of the situation that we find ourselves in. What does the central limit theorem say? The central limit theorem says that, well, it really has two parts, but it's talking about the original data from the population. So there's really two parts to the central limit theorem, which we abbreviate as the CLT. But what it says is that if the population data follows a normal model, which would look like this, mu and sigma, then any sampling distribution for any size n follows the model we see above. Same mean with the new smaller standard deviation. The second part of the central limit theorem is talking about data that is not unimodal and symmetric. So this whole first part says that if the data does follow a normal model or is unimodal and symmetric, then that means that we can use the sampling distribution no matter the sample size. The second part says if the population data is not normal, so maybe it's bimodal, skewed, or something else that makes it not unimodal and symmetric, we can use a sampling, but we can assume, we can assume the normal model applies only when n is greater than 30. So it would be the same model that we see above, but we can only use that sampling distribution when the sample size is larger than 30 if we're told that the population does not follow a normal model. So that could be important specifically in our online homework where we're asked in section 7.3 about whether or not we could apply a normal model to a particular scenario. Okay, so keep that in mind as you're thinking about any reference to the central limit theorem, that if the data is not normally distributed, as long as n is bigger than 30, we can assume that it is. All right, let's see some examples for 7.3.